I was going to say good morning, but I don't even know what time of the day someone's listening. So, hey,
Hey, good morning. Well, it's afternoon here, evening.
I know, but who knows when people are what if people
Oh, you
listen to
weren't saying it to me, you're saying it to everyone else.
Yeah, well, should we start again?
No, that's good. Roll
Hello,
with it.
good people.
How are you on this morning, afternoon, evening?
I'm good, bad / okay.
Yeah, that makes sense.
There we go.
Who'd we have on today?
We have
Bob
Bob,
Kelly.
Bob Kelly from Wickwright. He is currently at a building science summer camp. So we talk about that for a minute, but he is he has basically dedicated Wickwright, his company, to what he deems vapor release systems for flat roof details. And simply put, for my little brain, is these masonry parapet walls that have this rubber roof that comes up and over them, and they're being capped with sheet metal, is a huge issue, and it's causing tremendous failures. And if you go to his website, you'll see some of these failures, and we do our best job, Tyler and I, kind of talking about the technical side of it, but also how we got here. Masonry buildings are hundreds and hundreds of years old, and why are we dealing with these issues now? We talk a little bit about building science in general, and just are we making things more complex than they need to be? Are we truly thinking about how to build the best building, or are we simply reacting to issues that are being presented to us, driving us to this land of kind of never ending problem solving?
Yeah, it was an interesting conversation. I think realistically, just nothing that I've really put much thought or consideration into, and it's always enjoyable to somewhat dissect a problem or an issue that you're seeing being exposed to or that you have familiarity with, and then realizing that, like, hey, this is probably more common than you realize, and how simple of a fix it can be. So it was interesting to look into his theories and his concepts and what he's been doing and the systems that he's creating. I definitely enjoyed that. So I hope you guys enjoy the conversation as well. It was a fun one for us. Bob, super knowledgeable, very humble guy, and I think you guys will enjoy this one. It's very interesting, at least for me. So, this podcast is brought to you by Andersen Windows. We were unsure as to why the lift slide door was limited to the 60-foot width. And we were speaking a podcast or two ago about why, and Ellie was going to get us answer on that. And unbeknownst to myself, she had gotten us an answer to us, and it's kind of slipped through the cracks. So, the lift slide door can be over 60 foot wide in a custom order. Requires a bit more design fabrication than is outside their standard system. So it's a bit more expensive, but definitely can be done. And they've done up to 100 feet
100 feet?
wide before. Yeah. So
Woo!
we
I
were
want to see
wrong.
that.
We were wrong. It can be done. It's just not within their standard system. The 60-foot reference point is because the maximum length to build and ship a head jam is 30 feet. And their standard lift slide system configuration allows for one splice to be used to allow two head jams up to 30 feet each to be connected during installation to create one continuous 60 foot of head jam, if that makes sense. The multi-glide door is very similar. They spec the multi-glide door at a max of 50 feet, the width. That's because the max lineal that they can build and ship is 25 foot in length, same splicing requirements. But the multi-glide door design allows for that splice to be installed in the field to get at that 50-foot max. So unlike the lift slide, we do not make custom lengths on this door. So you're going to be limited with that multi-glide to 50 feet, but the lift glide, they've done up to 100 feet. It's just a custom order at that point. So everyone now has the proper and correct information brought to you direct from the horse's mouth. So thank you, Ellie, for that information, so Nick and I can stop making stuff up, at least for today's episode. So it's brought to you by Andersen Windows. Check them out for all of your window and door needs.
This podcast is also brought to you by Buildertrend. If you've tuned into the Modern Craftsman recently, which I think you probably have since you are listening to this right now, well, then you know we're big fans of Buildertrend's construction software. They've got the tools you need to work simpler, impress clients, and drive growth. But what it is that really sets Buildertrend apart from all the other tech options we have as builders, well, it's their support. They understand that learning new processes, let alone a whole new platform, can be intimidating. And that's why their team does everything they can do to make it as simple and seamless as possible. One of the best ways they get customers up to speed is their live trainings. Available for all customers, they have a calendar jam-packed with tutorials where a product expert walks you through how to best use a feature. Don't waste time fumbling around and wondering if you're doing things right. Get in the system, get what you need, and get back to your day. Buildertrend makes that easy. To learn more, visit buildertrend.com/MC support.
Hey, how are you? I'm Tyler.
Hi, Tyler. Nice to meet you.
Nice to meet you.
What hotel are you at? Or where not specifically. I just mean like where in the country are you?
Well, I'm at Joe Stebrick summer camp.
Wait, so that's up in Maine, right?
Westford, Massachusetts.
Oh, it is in Massachusetts. Oh. Is that invite only? What's the deal with that?
Yeah, it's invite only.
How do I
But
get
there's
an
a lot
invite?
of,
Because I'm like an hour from there.
well, you should call them up and say, hey, I want to come to summer camp.
All right.
They're looking, last year it was a announcement made that they need to have new young talent coming into the fold.
What is it?
It's it's called summer camp. And so Joe Stebrick invites 500 forensic type engineers, architects, contractors, building envelope specialists. And there's 3 days of talks. I think there's about 4 talks a day, 2 in the morning, 2 in the afternoon. And then a lot of really good food and drink at his house at night.
Most importantly.
It's called, I would say, building science debauchery.
I did not realize that there was 500 people. I thought this was like, I literally thought it was like a dozen of you guys.
Now you feel really badly that you're not invited.
Yeah, there's 500 other people.
You thought this was like Willy Wonka, the golden ticket?
Yeah, exactly.
It's kind of like,
yeah,
Everyone gets in.
It's like literally every single person that is in building science is there.
If they let me in, they'll let anybody in, trust me.
So you're there now, you said?
Yeah, I'm in my hotel is just a block down the road.
So what day are you on?
Day 2.
Day 2.
So there are some people who came on Saturday night, and there are some, special gathering. They had steak and lobster, and then Sunday night was a big dinner. A huge spread of food. I mean, you don't serve 10 shrimp; you serve 100 pounds of shrimp. Last night there was they call them cowboy ribeyes.
500 of them.
500 of them, and that's a third course. You can barely make your way off your chair for the third course.
That's so much steak.
It's amazing. It's amazing. Complete gluttony.
So you said it is invite only. How did you get invited?
I got in because there's a guy I'm connected to on Instagram, Michael Anshell from OA.
Okay.
And he knows about my work in Chicago, and we're good friends. So he called up Joe Stebrick and said, send this guy an invite.
So
I got one.
We just got to call Joe.
I think so.
Okay. All right. Gonna
So
need his phone number.
You're based out of Chicago?
Uh-huh.
Yeah. I was looking at your background a little bit. If you want to quickly give us like the overview, it looks like you were an interior carpenter initially.
Yes.
And then you switched to what you're doing now. I was interested in that switch, but at least if you want to brief all of our followers who are unfamiliar with you as to what your background in the industry is, and then we can go from there.
Well, what's the best way of saying my background is I've always been tooling around, fixing things, breaking them apart, I was very destructive as a child. Okay. So I'm sure you guys were as well, because otherwise we wouldn't be carpenters learning how to put all the stuff back together.
Yep.
And, well, I worked my way through college working for my brother, who is a cabinet maker, remodeler on the North Shore of Chicago. And when I got out of college, I realized I knew more about carpentry, drywall, and framing than I did about geriatric psychology that I studied.
Yeah,
So
that's a big switch there.
yeah, a little bit of a switch. But I was lucky enough to apprentice under two master craftsmen. This guy named Randy and another gentleman, Victor. And Victor kind of took me in as somewhat of an adopted child of sorts. He took me under his wing, and I'd spend all these early mornings with him. He taught me how to turn things on the lathe, grind knives, all in the morning before hours. I'd meet him at the shop around 5 o'clock in the morning. Yeah, and then I was really fortunate. I really took to it, and then I started my business after being with him for a couple of years when I was 26.
Was that mostly interior work that you were learning at this point?
Additions on
Okay.
old Victorians on the North Shore. So the goal was always to, when you get to the job, when you're done with the job, you copy all the details, you grind the knives, we build the cabinets, we put in the foundation, we solder the copper gutters. And then, and when you're done, there is no trace of you being around. Everything is seamless. And so that was my direction.
And you guys were self-performing a lot of that, or managing, or a combination?
Self-performing.
Yeah, that's cool.
Yeah.
I feel like on those old Victorians that I don't know, that's somewhat of a dream to be able to go in and have the time and the capacity to go foundation to finish and restore and mimic all those details. There's so much going on. It'd be so cool.
It's pretty amazing. It gets you out of bed in the morning.
Yeah,
But
and I feel like even now it's more about specialty sub trades and not as much self-performing. So I think it's harder to find outfits that still do all of that in-house without going to other companies and finding people who specialize in different things. Just like the amount of knowledge that you have to be able to complete one of those projects is extensive.
mm-hmm.
I love the idea of self-performing everything. And I think that, even now, like, we manage so much, but there's times when I'm on a job site where, there will be like, that gray scope, right? Where it's you're not sure who we're supposed to have do it, where it's like, why wouldn't you just hop in there and I'm talking to like a super or something like that. Why don't you just do it yourself? It's like, or I mean, I'll go get my tools and I'll do it. Like, it's not, we get sometimes we get so wrapped up in the mindset of everything has to be performed by someone else. That's not, my job is to manage it. And it's like, I get that and I agree. And it's like, that's how, we're structured, but there is something nice and something, appetizing about just, handling it. Just taking care of what needs to be taken care of. Obviously, you're talking about the extreme example of pouring, placing foundations all the way to soldering copper gutters. But there's a lot in there that you just do because you're the guy that can get it done.
What's really interesting, I think the learning process is really the key, right? Because as you're taking it all apart, you're also at the same time learning how to put it back together. You see all the nuances. The guy from 1864, how did he put this thing together? What size nails? Whatever, and it's just, and you see how the building, that's where I learned how building envelopes were healthy. Those are the first rain screens. Like on a stucco house, they've always got, furring strips, and they put their wood lath on and smeared it with some stucco, and then stuff is healthy forever. Pan flashings, right? I got one client who's got a 1890s house in another northern suburb. The galvanized gutters are incredible. They're in perfect shape today. He's got these round turrets with compound curving bevel siding. It's just amazing to see, these old works of art. So tell me a little bit more about your businesses. I'd like to hear your background too.
Go ahead,
So
Tyler.
I'll go first. I am a residential remodeling contractor, smaller jobs, specialty work. Biggest thing I would get into is, in addition, we are going to be building my own house here shortly.
Hmm.
But smaller projects, attention to detail, just being involved with the industry on the residential side of things as much as can be. But I'm hands-on, belt-on contractor. I do
Hmm.
manage some, but I'm still wearing the tool belt every day.
That's really cool. How about you, Nick?
A little different. I was for a long time built on contractor. Started my business as a carpentry company and was a carpenter with sporadic help. And we started growing, taking on bigger projects. My goal, and my dream was always to build homes. And started building a team of other carpenters. And eventually, that turned into building project managers or hiring project managers and fast forward to today, and we're a team of 15 that we have, directors of operations and pre-construction and project managers and site supers and carpenters. So my day to day is very much business oriented now, and I don't get to put the tool belt on really at all. But I do thoroughly enjoy being on a job site and helping through problem solving and creative thinking. I think that looking at my career, I realized that's where I'm strongest. I was a decent carpenter, um, mainly because I just would do it until it was perfect and waste material like it was my job. But or not perfect, but as good as I could do it. But now I very much allow the tradespeople to do their job and come in and be the one that usually interrupts their normal way of thinking with some ridiculous alternative way to accomplish something very similar.
Awesome.
Yeah.
How so? For everyone who doesn't know what you do nowadays, it's a little bit different than the interior carpentry and Victorian home remodeling. You're specializing in low slope water management with low slope roofs,
Right.
split face block, and also something that's super interesting to me with your temporary roof systems. How did you get into this, and this being your focus and your new business, or not new business, your separate business with the materials company? How did that come about?
Back in '98, I bought a house that I thought I was going to fix it up and flip it. Well, at the same time, we were living around the corner. Um, my wife at the time and I had a huge family, and I was always looking for um, the low-hanging fruit of sorts, and I always found it with water management details. After '08, in '08, I built this fabulous staircase. There's probably time and material until we got up to about $700,000. There was an ebony inlaid, teak, mahogany, red oak, you name it. We threw everything at the staircase. And then '08 came, everything blew out. And so when I started, I really developed a love affair with sheet metal. The art of joinery has always intrigued me, right? And I'm not really concerned about which materials. It's just how everything does get put together. Because, I mean, anybody can run crown molding, but it's the miters that are perfect, right? Or the sheet metal. I mean, you got a standing seam roof or a nice drip bed, pan flashing. It's all about the connection. So um, I bought this house and I needed curved copper valleys because I put a 1812 turret, curved roof with that curved out to a 912 pitch on a 12-foot diameter radius, living room on the second floor of my house. And I needed curved copper valleys. So this guy came out and he made patterns out of tar paper, and it absolutely blew me away. He laid it all out on the ground. It was all flat. He soldered it together in place. And I was so amazed that I just everything I wanted to do, I wanted to just learn more and more about sheet metal fabrication. So over time, we were running into these jobs in the city where there was always condensation behind the roof membranes, and there was always some kind of rotten plywood, and we had to figure out how to dry them out. But I started to understand that, sheet metal will cap off your substrate, it'll shed water, but allow air to flow out from behind it at the same time if you create enough spaces. So having this knowledge, we were finding these masonry buildings were wet, and we discovered that if we decouple the roof membrane from the inside of the parapet wall and decouple the mason flashing from the top of the wall and allow the air to blow through, we were able to dry out an entire building. And the way we use that is we use corrugated plastics because it's a hollow, rigid extrusion.
And so was this on residential projects that you were running into this?
Yes,
So what were
all residential.
And were you doing work on the inside and finding moisture issues, or were these complaints from customers, or how were you even coming about? Because for most people, right, if it's a block wall or a stone wall, the water that is present within that wall may not be super obvious until it reaches like a full saturation point or a point of failure. So how were you coming about these issues?
Well, the source of work was actually directed from home inspectors who knew that I was experimenting with these buildings. And so they would get calls from their clients. They, had persistent leaks and they had mold smell. And, a lot of my customers have already paid 30 to 50 grand in labor just caulking things back together, people trying to seal them up. And so the home inspectors saw that I was experimenting with trying to get the water vapor out. And I just kept on getting referrals. And then we did one job, and the mold smell left the house. A friend of mine was a home inspector, but just retired. He pulled a capstone off the top of a house and got hit with a blast of hot, wet air. And so he came to me and said, I've got this problem. And we experimented with the fabric on the back side of a ridge vent.
Yep.
Called unbound polypropylene. But we took that fabric and we made two lines of basically a barrier, and then we placed sheet metal on top of that fabric with blocks, and then we put our stones on top of that. And also we used a similar idea. We took the roof membrane off and we put a gap behind it and capped it off with like a sheet metal umbrella. Well, that job was successful. They dried out the house, and it was a chance. The guy was a researcher at Northwestern University here. And we're like, we don't know what to do, but we know that we got to let this stuff out. And so we did the job, and about a month later, they let us know that the mold smell had left the building.
So essentially you were brought in because there was a mold smell. They assumed there was moisture in the walls. You guys confirmed there was moisture in the walls. And now it's like, hey, how do we get this moisture out of the walls?
Exactly.
The only time I've experienced that is there are a lot of block foundations around here. And when we put French drains in after the fact and you're drilling weep holes in the CMU block, the first time that you do that, where you have your dimple membrane on the interior of the foundation wall that's then bringing you down into your stone of your French drain, at times you'll punch those holes and water will just come squirting out of those block walls. And that's block that's not a full, it's not 2-3 stories high. It's maybe 2-3 feet above grade level, and there's still a considerable amount of moisture getting in. So obviously, if you have the top waterproofed, water and moisture is not coming in through that capstone unless the waterproofing goes bad or if there's a metal flashing. So how's the water getting into these buildings in the first place?
Okay, that's a great question. Well, it's an internal condensation problem. These buildings are sealed up so tight on the outside that, and oftentimes you see roofers run the modified bitumen or the roof membrane over the top of the wall to try to keep the water from coming in. Well, in fact, what they're doing is every house that I know of isn't air sealed. And then moisture gets up into the walls, and the stack effect actually accumulates underneath the roof membrane. And over a period of 10 to 15 years, it'll start to rot in different areas around the perimeter of the roof. So you can have condensation on a dry day. You just need a difference in temperature of about 20 degrees.
So
So
then you have moisture that's from within these walls that essentially started post construction potentially and just has no way of drying to the outside of the house.
exactly.
It's crazy to think about because most people see a masonry home or even commercial construction and they're like, well, we're good to go. There's nothing to rot. It's all stone, it's concrete, it's mortar. But you run into issues where any sort of wood structure that is either let into this block or in contact with this stone is rotting away, right?
Correct.
And you
So
got, go ahead.
no, I'm sorry. After you, please.
And you guys are also part of your business doing the repairs to the structure when you find that it's rotted away.
Yes. Yeah.
And
What we do is when we do a venting system install, because we're basically, the magic sauce is really using dimple board that's laminated to the back of high density polyiso. It's got a fiberglass skin to it. So we're creating a gap at the parapet wall. And in those drawings, I've got the roof membrane connected to the flashing on top of the parapet. So it overlaps one another. So when the wind blows through, it creates negative pressure, and it's a drying effect plus it's suction at the same time. So like in Chicago, for example, the average wind speed is about 18 miles an hour, and 18 miles an hour can create a negative 7.2 CFM draw in your walls. And so there's no water getting back in, but it's always coming out.
that's crazy. I I was listening to a recording with you and discussing about how you guys are actually going through and repairing the trusses that you're finding damaged and the temporary roof structures that you guys are creating to do this work within the city. Was this all just created out of necessity, or was this like,
Yes.
hey, I have this idea that I could monetize and run with business, or is it just like, hey, we can't do our job otherwise?
No, it's all out of necessity. So,
So can you, yeah, explain to our listeners who are unfamiliar with what you're doing, but like in a situation like this where you come in and there's moisture issues with a project and you know that there's no venting at the walls or with the roof system, what you guys are doing to go in and set up to do a job like this, repair the rotted structure and also vent these walls, but obviously being able to work without shutting down the shop, getting people out of the building, and keeping everything outside.
okay. So, there's different layers to this, right? So, you've got some moisture, you pull back the roof membrane and you see rotten plywood. Okay.
Mm-hmm.
And also when we're doing a venting system, I like to cut back the roof about a foot, and I do a close inspection to every single truss in the building, because I just don't trust anything anymore. So you peel back the first layer, the plywood, then you peel back the plywood and you see the rotten truss. Well, if there's only a couple here and there, well, you can kind of schedule a day, have 6 guys on the job, do the repair, put it all back together. But if there's enough damage, and then we have to build a tent. And what we did when I've got a little boat in Michigan, and I've been talking to the guy who owns the marina. I said, look, dude, I'm running into these problems. I need some kind of a cover. I want you to build me a canvas pontoon cover that I can lower with a crane. Well, he looked at me, and there's nicknames for people from Illinois, from Michigan. They call us FIPS, right? He said, you FIP, you're crazy. So anyway, a couple years go by, and I run into a building that half of the trusses were toast. And
Wow.
we could still walk on it. So I called them up and said, look, get your ass down here. I need a roll of shrink wrap. And I made a frame out of PVC pipe.
Mm-hmm.
Then we stretched the whole building with a roll of 10 mil boat shrink wrap that's about 40 feet wide and 120 feet long. And then we shrunk wrapped the whole thing down with a torch, and that was our first tent. In fact, but our first tent was a massive failure. But it was a great idea, but it was a massive failure. I used the regular PVC pipe, the Schedule 40, the white stuff.
Yep.
And and a big wind came in overnight and collapsed the tent. I lost about 15 or 20 grand. Okay. But in the process, I knew it was still a great idea. So we rebuilt it. We shored up everything. I used Schedule 80 pipe this time. So we did a couple more of these tents out of the PVC pipe. And that's really been great. But now we got an aluminum rafter system that I've been in 65-mile-an-hour wind gusts. And we put a 4200 CFM fan in the gable of the tent, and it draws down the plastic, so it keeps it secure. And then we rip off the entire roof system and do the truss repairs, and then put it back together.
And did you develop you said it's an aluminum frame system?
Yeah,
And you developed that?
yeah, I developed it, and I was all out of desperation, for sure.
So you essentially can break that down. It can fit multiple setups, different sizing. So it's not necessarily one size fits all, but it's not like you're building a frame structure for each specific job.
Correct. The way I've got it set up is that it's it can be adjustable. I can cover a building that's 25 feet wide. Now in Chicago, an average footprint is 20 by 70 of your building, and so, and that's worked out. We've done about a dozen of those, but now we've got one job where one of my buddies, the GC, he's tearing out all the trusses, and he hires us to be the tent builder. We're not the
Yeah.
carpenter or sheet metal guys. We're just the tent builder. So that one is 30 by 40. And this time we used 12-inch open web trusses as our rafters. And it's worked out. It's working out great. In fact, it's up right now, and the guys are ripping out all the trusses right now.
Yeah, I was going to ask you if you're performing that just for yourselves or for other people as well. Like, is that a business avenue that you're looking to explore, or have you already?
Um, yes, but it's not too often that people are calling us for doing this task. We're not really that well known. I mean, we are known, but to that extreme level that people realize that, or they don't realize that by spending the extra money for a tent, they're actually saving themselves about 100 grand. So I'll charge about 30 grand for the tenting, because it takes, it's a 5-man crew, about 3 days to put it together.
Yeah.
And then there's maintenance that we do. And, but at the same time, nobody has to move out. We're protecting all the interior finishes.
Mm-hmm.
And so we're saving them about 100 grand by doing this.
And Nick, if you see the way that they set these up
I'm
with
looking
the
at it now.
exhaust fan, and then even all the pipe penetrations for the stacks and the exhaust that are coming out of the building, so that you're not killing everyone working underneath the tent with carbon monoxide.
Yeah. I mean, it's
Hopefully you didn't learn that lesson the hard way.
Every lesson has a learning curve, right?
So I have a general question. I was looking at a lot of these section views as you were talking. Are these details implemented in new buildings, or
Yes.
are they but like, is that standard practice now? I feel like I still see buildings go up and not put a vented sheet metal cap on a parapet wall.
No, nobody does a vented sheet metal cap. That's the thing.
Still,
It's still, yeah. I mean,
so and this is a huge issue.
yeah.
So I'm thinking, like, I mean, I talk about this so much on this podcast, but I'm watching these buildings be built in and around where I live in Boston, and there's a mix between masonry and then just like a hardy plank siding. And my wife and I have a bet going, when the building's done, how long until a boom lift is in front of that building? And because there's going to be a leak. There always is. I watch this stuff. It gets built extremely poorly. No one's detailing things correctly. They have these complicated cantilevers, and next thing you know, 4 months after the building's done, there's a boom lift parking in the street, and no one knows anything better. And then the siding gets ripped off. But there's a building in particular that has efflorescence all over. It's all masonry. It's got a parapet at the top, And I don't know what the detailing is up there, but I'm sure it's wrong because I watched them also stick steel through the envelope,
Mm,
uninsulated, that, ties back into the floor system behind it, and it's supporting a bay window, and it's like that's gonna condense.
yeah.
You're gonna have mold issues, and it's super frustrating that this stuff continues to get built. I mean, there's a building in Boston close to where I live that is no more than 5 years old. And I watched scaffolding go up around it about 4 weeks ago, the entire building. I'm like, man, I wonder what they're doing. They removed the entire brick facade, not just pieces, the entire brick facade.
Right.
Brand new building.
They didn't have to.
Well, I don't know what the issue was, but regardless, it's like this is what we're dealing with. So where my question's going is, why, if this is an issue all the time, and you have created a solution for it, why isn't it normal practice?
Because I'm fighting tradition.
And why? Okay, so that's a great point. Why was it different? Like what? Why did the old buildings not have this issue?
Okay, so let me just drag you through the rabbit hole of history of
Please.
my little bit of knowledge of how the changes in the industry have taken. So what I find fascinating is that, old Boston, old Chicago, Europe, right? All the materials are soft pottery, right? Soft fired clay, and it's very absorbent. Well, what's even softer is the pure lime mortar. So there is no Portland cement in
Mm,
lime and sand. Portland cement is like the red dye in Bondo.
mm,
It's an epoxy additive that makes lime and sand set off like regular concrete. So, I mean, Portland cement was introduced into the marketplace through our buddy Edison, who understood the metallurgy. He finally got metal hard enough to crush Portland cement, and that was invented back in the 1800s. So now we got this powder that you can, make everything a little bit harder, and then over time, what's happened is that coal-fired furnaces have been replaced by blast furnaces, and our mortars are getting harder. Well, the old lime mortars would suck the water out of the wood and the brick and exhaust it to the sky. And then there's no insulation in the building. So now our buildings, it's really important to understand the concept of inward drying, because masonry buildings have to dry to the interior. So lack of insulation also created almost like an interior rain screen.
mm.
But parapet walls go bad on old buildings because that water vapor is rising up, and then it breaks down the lime at the roof level, and there's nothing left except for sand. But if you could have that vapor path continue all the way through, you'd never have a parapet wall to fix. So anyway, so then you fast forward to today, and now everything's a lot harder. It's storing materials, but you can still dry it out if you allow the suction and the vapor path to continue all the way through, and that's what we're doing. And it's actually fairly simple, but things have changed so gradually over the last 100 years. I don't think a lot of people are paying attention.
So the issue is that buildings essentially we're sealing them better from the inside and outside, and that water that's getting in, and once that sealing or weatherproofing on the exterior of the building wears down or fails, it can't dry to the inside, and now it has nowhere to rise and dry out through the top of the building either.
Correct.
So it's just trapped in there.
It's
It is crazy to think about, where it's probably one thing that changed, and then 20 years later, there was no ill effect from that, and then somebody else implements something else, and then you fast forward 100 years, and all of these things that we've implemented to build these tighter buildings, and the way that we've constructed things, where you really haven't been able to gauge the overall impact of that, or it hasn't presented or shown itself in some massive catastrophic failures all at once, how those changes affect our buildings. And it's not until things start to fail that you question, why are they failing, and is what we're doing correct? I've always lived in old homes, but I did a repair on an old Victorian home that was a couple hundred years old, and I repaired the cedar siding that was on the outside of the building, and it was essentially cedar siding over just clapboard, and then balloon framed walls with no insulation. And I'm like,
Okay.
geez, how is this not all rotten? It was in perfectly good shape. And then I realized, like, water's getting in. It's getting into that cedar. It's getting into the clapboard, but then there's essentially no insulation in that walls. You have lath and plaster on the inside that it can dry through. So it's like, yeah, there's moisture getting in, but there's also moisture getting out. And it's just a very simple system. And what we do now, there's ways to prevent moisture from getting in, but when you have a masonry building, like, it's gonna absorb moisture. There's nothing you can do to prevent that. So it's the thought of, hey, we need to be able to get this moisture back out would seem as though it would be pretty elementary.
It seems like it should be, right? But like you mentioned about drilling a hole into your CMU, I mean, I've done that a handful of times, and I've had water squirting on my face. I even in my own house, I've got a cinder block foundation. I mean, I bought my property because it came with a big pole barn for my cabinet shop, and it came with the house. So, and it came with the house also came with a squeegee. Okay, so when I was putting in drain tile in my basement, I was like, hey guys, let's give it a try. Let's drill a hole, and there was no sign of moisture at all. Freaking hole drained for like an hour.
Yeah.
And that's just it's crazy, right? The other thing that concerns me, I've been giving a lot of thought to, our lumber inventory. Like, I've got a job going on right now in in a northern suburb where I'm taking all the stucco off the house. 7 years old. They had no rain screen. They got open cell foam on the inside, but behind the house wrap on the 1/2 inch CDX, I'm finding not yellow mold, but it turns out it's just a huge mushroom in different areas, and it's devouring the plywood. And so it's like there's so much less resin in the farm lumber that we're using, and so much more phylum, that I think we're actually are the products you can't. I don't think you can avoid dealing with this in some respects. You got to have a really active rain screen. I'm not even sure what insulation to use on the inside. Maybe rock wool, So
it just doesn't seem like it would, as long as you are, like, with masonry buildings, the thing that bothers me, is that, and it's the same principle with shower pans that people build and everything else. It's like, well, if it gets wet, it doesn't matter because it's not going to rot. It's not wood. But it's especially important with something like masonry, where it just absorbs water, that you have to deal with getting that moisture back out. And that's a problem for me, because most contractors have that same mentality where it's like, hey, it's almost like you absolve yourself of all water management responsibility because it's masonry, when in fact it's almost more important, because that stuff holds moisture and it hides a lot of issues. I mean, I'm running into massive issues with poorly installed flashings and stucco on a house right now that's costing the customers tens of thousands of dollars to remediate, and it's because water got in and they didn't allow for water to get out. And then once they realized water was getting in, they caulked everything, which made it even worse because now it really can't get out. And it just, the thought process behind masonry construction, to me, it's I see where people are getting it, but at the same time, it's even more important to get this water back out. And this is, to clarify, this, what you deal with is typically with like single wall construction, right?
Both brick and
Okay.
block.
And that would be, would it, so it's the same thing if you have a brick wall, are you running into these issues with brick veneer where there's an actual drainage plane behind the brick, or more so like a traditional double wide brick wall that core's filled?
Okay, I'm going to say all of the above.
Okay.
So, okay, so let's say you got brick veneer, and
I feel like that's most common for, at least around us. It's primarily brick veneer.
yeah, right. But but there still has to be that rain screen. You can't be bridging the mortar. It's so often that the mortar snot is smashed up against the house wrap, and then you get this hydrostatic pressure on the back side of it that you can't get rid of because it's holding the water, and then it's going to penetrate through. In fact, it's interesting that I was talking to somebody this morning about how when water penetrates through the fasteners, then there's tannins are released in the plywood, reverse affecting the house wrap, breaking it down and making it even more vapor open than it should be. So it's like this ongoing cycle of, it's just a downward spiral. And then the buildings break down over time, but it's a 15-year process.
I mean, it's even so when I think of brick veneer, and you have these tiebacks that are holding the brick to the wall, I feel like every detail that I've ever seen or looked at like distinctly shows the brick being isolated from the substrate, and it still somewhat befuddles me how people are not abiding by that, like not creating or upholding that drainage plane behind it, right? Because that, if you had that drainage plane behind it and the proper weep holes for the water to get out, this would be a non-issue.
Right. And so these guys talk about having a 1-inch gap or a 2-inch gap, whatever. But the easiest way to do it is to buy the entangled mesh that, I'm not getting paid by Benjamin Opdyke or Stucco Flex or MortarNet, but these are all products that have that entangled mesh with the fabric on it. That's extremely vapor open. It's just kind of a filter. And then you put your brick ties through that. And because if there's any water that travels on the fastener, well, the surface tension is going to be broken by the plastic that you're going through anyway. And so the drainage plane is, it's all clear. And so my thing has been having a horizontal rain screen, venting the top of that rain screen.
Yeah, that's an interesting point. So explain what you mean by that. So for people, obviously this is an audio podcast, but what do you mean by a horizontal vent for your rain screen?
So let's say you got your freeze board. At least that's what I call the board just underneath the soffit. So let's say you got a 3/8 gap. Your rain screen is back there. And then we'll block it out with corrugated plastic. We take thin layers of corrugated plastic and glue them together in our shop. And then we rip them in strips so that, when you put your freeze board up, you're going up against a piece of corrugated plastic. And then you have your siding, okay? And then you got another layer of corrugated plastic. So now you're creating like this J shape of airflow. And then you put your freeze board over the top of that. So when you look up, all you see is a black shadow line. And you recess the plastic enough so that you don't even notice it, but it's there and it's constantly working. So we have to take our finger off the top of the proverbial straw, and every time we do an exterior.
And is it necessary in that case to have some sort of venting at the base of that wall as well, or is that more so just for that heat and moisture and humidity that's building up behind there to be able to rise to the top, or does it need like an actual draw of air from the bottom?
It's better if it does have a draw, but like in the solid, like common brick buildings or brick and block, you don't need to have air intake because there's enough hollow cavities, and there's also the wet to dry effect, right? You can't stop that drying. Once you start the drying on the top, it's always going to retract the moisture from below, and you can't stop that. So this is how we're able to put a cycle of health into the building.
Yeah, go ahead. Sorry.
One thing is we're trying to get these things to dry three-dimensionally, either single width or triple width or brick and block. One thing that we should pay attention to is the use of foams and versus vapor open insulation, because if the building can't dry three-dimensionally, then you're going to have hydrostatic pressure that will never dry out completely. So this is the biggest problem using foam in a masonry building, is that you'll rot the wood that's sitting in it in very short order.
What do you mean the wood that's, so what if you don't have wood sitting in the masonry?
Then you're in better shape, but the brick can also start breaking down from freeze-thaw cycles.
Because it's getting wet and can't dry, and then it freezes and it spalls.
Yep, exactly.
This is what I we have a project where I think it was the inspector and the installation contractor came out, masonry building, and they were like, let's just spray foam it. I said, no, you're not supposed to be spray foaming the backside of brick.
Good.
And he's like, we've done 1,000 of them in this city. And I came across an article shortly after that conversation of a brick building that collapsed. And in the article, I didn't actually read the whole article, but in the article, it said that it was due to the use of spray foam on the backside.
Mm-hmm.
And I mean, it was a substantial collapse. How likely is that?
Very likely.
And that's scary, because that is all of these brownstones. And I mean, Boston it's millions of dollars that these people are spending on these buildings.
Mm-hmm.
And I'm watching foam go into every one of them.
You guys, this is going to be the next, FEMA kind of thing. I'm really concerned.
Yeah,
truly,
that is an aggressive analogy, but I can I can understand. I said something similar. I was like, there's going to be a wave of brownstones that fail dramatically in I don't know how long, because I wasn't invited to the summer camp. But
well, maybe next year.
but there's no doubt, like, this is going to be an issue, and it's not if, but when. And this goes. So I want to ask a question similar to this. Austin was on the podcast a couple weeks ago, and he builds solid masonry homes. And one of the things he said on there that kind of made everyone perk up was that there's almost too much focus on building science. And that, in something you said a little bit ago about, people have a hard time breaking away from tradition, but also that the buildings were built differently and they weren't insulated as much. And, I think that there's probably a fair amount of people listening to this podcast as you are explaining what you're doing and walking through the details, that people are like, this is just way too overwhelming. There's vent this, vent that, rain screen this, rain screen that, got to do this, why don't we just build buildings the way we used to? And I'm not a proponent for that in all cases. Like, I think that, especially wood buildings, like especially air quality, I think is like a priority. But in these masonry buildings, and creating all of this complexity, is it, what's your thought in terms of how complex buildings have got, and how it relates to the how complex buildings have got, and how it relates to the actual benefit that it's providing for either the environment or natural resources, or so on and so forth.
Okay, so I'm going to sum up that question by saying, what are the buildings, how are they being built, and what's the benefit of these things from like a building science perspective?
Yeah, I guess there's a
it seems
long-winded way,
like
but like we're we're
it's
we're we're insulating them at such a high level. We're creating these super airtight structures. Then we're dealing with all of these failures because then the facade can't dry. Where it's like it's almost like we swing the pendulum one way and then we're like, shit, we got to go back the other way. And it's like this back and forth, and eventually this thing gets to a point where you're swinging so far in either direction that it's hard to reach center again.
Right. Okay. So, I mean, building science is a wonderful thing, right? But the thing that I don't appreciate about building scientists, generally speaking, is that a lot of people speak, I don't know, hyperbole would be maybe one way of describing it. It's like in the perfect condition. Well, you should do it this way, and you should do it that way. And, not acknowledging the human challenges of the level of perfection that all these products demand from craftsmen. You've got to have an out. Every time you do a job, you got to build in some kind of a trap door to, get yourself out of a situation. You're going to make a mistake.
Mm-hmm.
The foam's going to be at the wrong mix. It's going to be too dirty. It might be too cold and it shrinks. And I think the shrinking is actually one of the biggest problems.
That's why we don't
That,
use it. I've
yeah,
had it
right.
fail. I've had it shrink 3 inches in rafter cavities.
Oh my gosh,
It's terrible.
that's insane.
Yeah.
So making a house high performance and tight. Let me give you an example of a job we did in Florida. It was like an early experiment. So the guy was building a 9,000 square foot house out of split face block in Florida. So I went down there and I had some corrugated plastic samples in my case, and I was going to suggest that these guys actually build like 2 full widths on their foundation and just build a house outside of the house, because I wasn't really sure how to keep the water from coming in. But I had a piece of this 1/2 inch thick corrugated plastic in my case, and I'm like, well, you guys have already poured the foundation, so you're not going to do a double house. So what if we just take this shit, pardon my French, and we cut grooves on the backside that line up with all the mortar joints and run it through the roof, and maybe if water comes in, it'll flow down within the venting panel and then drain out, or evaporate and get sucked out by venting the top. I've been venting the top of buildings, enough to know that it's going to work. I just didn't know how to manage the inside of the building. So anyway, we ended up creating this heat exchanger. It dropped the cooling load of this guy's house 20%.
Wow.
And so I found out about it because he was sitting on top of the parapet wall. And this is before they put insulation in the house. And the back of his legs were burning from the steam rising out of the structure. So, so the idea of like separating your energy envelope from your structural envelope became apparent. And so I think that's the way we have to be backing into these jobs to make building science successful and make the structure successful. You could build a refrigerator inside of a brick building, just separate it with a rain screen and have it vent to the top. So that's my way of keeping it simple.
and it needs to be kept simple. And I think that that's also what Austin was alluding to during our conversation. And I had to agree with him that at times we're overly complicating things, and I feel as though the value or benefit of one system comes at the cost of another.
Right.
We're going and we're putting so much energy. Well, energy probably isn't the best word. We're putting so much effort and resources into being energy efficient, but then it's coming at the cost of something else. It's like, well, how much money are we spending on these systems to be energy efficient and consuming natural resources, where to get to a certain perm rating or efficiency within the house, and like to build houses that way is not sustainable. So we're almost contradicting what we're looking to do entirely. And I think that as far as water management goes, what people don't realize is that the tighter that we build our houses, the more potential risk there is once that envelope is compromised, because you build something that breathes and water getting in is not an issue, but you build something that was never intended to breathe, and now you have a small leak that is almost unable to be distinguished where that's coming from, and it can wreak havoc on a house and the health of a home when everything's sealed up so tightly.
Okay, so you got on a good point. It's like, like the little bit of water that can get into a building. And back in the day when there's fiberglass insulation or, whatever, something vapor open, it could dry out. It wasn't a big deal. There's way more volume of air than the quantity of water that could affect it, right? But once you tighten down that wall cavity and you get a hairline crack, even with the same amount of water, now all of a sudden your substrate is in contact with an ocean of water, relatively speaking.
Mm-hmm.
And it's just going to cause a lot of damage. Now, I don't know how you guys are building, masonry structure in Boston, but I'm sure it's fairly similar to what's been going on in Chicago, where the structure is supporting the wood. But in so many cases, I don't think I've ever seen the end of a truss being protected by anybody. And so now we got this tree farm lumber that has low resin and high level of, basically pulp being stuck into a way more, a much wetter substrate. And now it's like, the word absorb is to go within, but the Latin prefix actually changes to adsorbing, AD, a surrounding of water, like it's running over a rock. And so there is no more absorption with these harder structures, but there was absorption with pure lime mortars. But that's also how it got exhausted out. There's so many layers.
I just want to make sure I understood what you said between absorbing and adsorbing, ab and verse ad. But you're saying that these masonry walls used to, and now I'm going to be all screwed up, absorb water, where it would retain water, and now water is funneling in and around that, basically making its way into the lumber itself rather than into the masonry.
Right. And it's passing through a lot easier. It's like comparing a rock and a loaf of bread in some respect. I know that's kind of an extreme.
That's a perfect example. I got you. Right. So the water is very much working its way around and finding something else to be soaked up by, which is this truss. That's Tyler, what you said. That's the hard thing, and I think I said something on Instagram this morning about mistakes and how we oftentimes try to correct them and make these little changes and like get it to be better, and it becomes very expensive to fix later. It's like, the moment you see a mistake, stop, replace it. Because if you try to, put a piece of trim in that you cut wrong, all right, well, and then you glue two pieces together, you recut it, the painter will take care of it, and then the painter tries to take care of it, and he can't do it, so he tries to do it again, and it just becomes more and more expensive to ultimately just rip out and do again, where you should have done it in the first place. I can't help but to think the same way here, where it's like we're adding these systems and processes to building science in response of something, where it's like, hey, we had an issue, let's add something to fix that issue. Where, and I'm not saying this is an example of it, but sometimes like you just need to start over. Where it's like, all right, well, sure, masonry walls were great back in the day, but you know what?
Uh-oh, Bob, there he is.
He disappeared for a second.
He was quick.
Yeah. But it's like, is it, when do we get to a point where it's like, stop, we just have to rethink this entirely?
Well, that's what it is. It's, Nick, it's so many little changes that affect nobody. It's if it were this, I feel like we use this analogy all the time. It's like getting fat. You don't realize that you're getting fat until you like see a picture from a year ago and you're like, damn, I put on some weight. like day to day, you don't notice it. And that's what's happening with our buildings. Even as far as the wood goes, I think of the old masonry buildings that the wood framing is let into the structure and the masonry from 150 years ago, and it's all oak beams that like you could build a boat with. And even if they were to remain saturated because we changed the way that our buildings operate and they can't dry, they'd most likely be fine. But our buildings were intended to dry. They're not drying anymore, and we are using crappy lumber that rots when it gets wet. So like there's so many little changes when you add them up cumulatively, it makes a massive impact. But it's the single change at a time over 5-10 years that you cannot gauge the effects of those changes that we're making until you start having catastrophic failures. And it's like, well, what the heck are we doing, and at what cost are we doing this for? Right, we're looking to make our buildings healthier, but at the same time, we are not digging into basic building principles and fundamentals. We're throwing that stuff out the window for these complex building designs where there's serious risks when it goes wrong. And I like the point that Bob made, that we're basing all of this on a perfect build. Like, what build is perfect? We're basing building these houses airtight, assuming that every single water management detail is executed properly, when we know that that's just not going to happen. And to me, that seems slightly dangerous.
Well, I think it's what Bob said. Like, you need to have an out, right? Where it's like, if something does go awry, and you do get water in a cavity that you don't intend it to be, how does it get out?
How does it get out? I've got a little analogy that I kind of live by. I
Better
remember
than the getting fat analogy?
It's pretty good. When I was in college, I worked for my brother. He was a super talented cabinet maker and remodeler in Chicago. Always did high-end jobs, but he never had an escape plan. Like, he would paint himself into a corner. Everything had to be like, you couldn't make a mistake and not cover it up. Now, I'm not saying that mistakes are okay to make. No, I love perfect work, but you got to design stuff that, when things expand and contract, you've got allowances for these things already, and that comes with experience, right? But every job you do, people make mistakes, and materials are imperfect, and it's like one of the reasons why I'm not practicing carpentry anymore is because there's no good wood anymore. I can't rely on a straight piece of, come on. When we started out, there was bunks of vertical grain Doug fir that were heavy and dead straight, and there might be one bad stick in a whole bunk. Now it's just the opposite, right? You might get 20 sticks in a bunk that are good enough to, frame your kitchen wall with, or your bathroom walls, and so you got something flat to deal with. And but I've moved into roofing and masonry because it's dimensional, it's reliable, the sheet metal's straight, and plastics are, everything's reliable.
So what are you doing now? You have a materials company that you're looking to use your ideas and what you've been doing over the past 20 or 30 years to help mitigate these issues with these masonry structures. So what is that company, and what are you specializing in?
Well, the name of the company is Wick Wright General Contracting, and so we were calling our manufacturing side, which is very small. It's just, we make our materials in my shop, and so so we're making our materials for this targeted type project. But those projects, as in my mind, everything has a related cohesiveness, right? And so you go in to do venting, you find these issues, or you go in for a roofing project. We're always going to be venting the roof, when we do a roofing project. Um, and fortunately, all these jobs. I mean, there's so many of these houses, all these buildings that need this help. That you guys, you got to come to Chicago, and I'll put you to work.
It's so it's this is not the type of work that typically interests me. It's I mean, I love like I feel as though what you did prior to this resounds more heavily with me as far as the Victorian homes, the older homes. But looking into what you're doing and how you're handling this, and how important and how simple this can be. And that's not saying that what you're doing is simple, but just from um a principle,
Hmm.
it's a very simple idea as to what you're doing.
Yeah.
To be able to get air through a wall in a masonry building really makes a lot of sense. But it's really neat to see something that I heard you say that I'm experiencing right now that I thought was really cool. Essentially, was that you realized when you got into this um, that typically repair work, the scope of the repairs is dictated by the customer or the homeowner, and how you're not willing to do that anymore. I don't know if you recall saying that,
Hmm.
or that makes sense to you, but if you could elaborate on what that means, because I know what it means to me and from my point of view and what I want to do with my business, but why we can concede to what customers want to do when it comes to a repair rather than say, hey, this is what needs to be done. Here are options here based on budget, scope of work, how invasive you want this to be. Why we just concede to what customers want rather than what we know is right.
You guys, that is spot on. That is awesome, by the way. So, when I meet a new customer, when we take on a new client, and I tell them, it's like I'm kind of interviewing every person to see if I want to take these people on as a client. So we have to establish ourselves, not dominating, of course, but you have to be firm. It's like, look, you've got this problem, and we know how to fix it. This is our specialty. So what I do is I don't go and give people a price on fixing their building, but I do give them a price to do an assessment on their structure. And the assessment allows me to take the time to kind of engineer the job in a certain order of egregious leaks at like balcony doors or windowsills, but at the same time, and do certain tasks in a way that demonstrates to them that this is a flawed system. So at the end of the list of things to get done, then I'll do the big deep retrofits. And the way that I win my clients over is I give them a history lesson on why we are here having this conversation. Because the biggest problem with projects are the client. Give me a price on a roof. I got water coming in. Well, guess what? I've seen one building. I saw 3 roofs in 10 years because they just kept on buying new roofs because the last one could have leaked. Well, it wasn't the roof at all. Flat roofs hardly ever leak when they're within a certain age because it's so easy to put on.
Hmm.
Right. And so, I get people, asking me for that. And I say, well, no, but I will do an assessment. I'll take control of the project. You just have to grab these people by the ears and shake them a little bit, or give them a big hug at the same time. And once you get them in the fold, then you provide them with structure.
I also
And
think that protects you and your business as well.
mhm,
Because essentially, I mean, I'm running into that on a job right now where it's like there's a roof above the area that we are working that is leaking, but it's leaking at a lot of the flashing points where it meets the sidewall of the building.
mhm,
So that there's some windows that are set too close to the ridge that even if we replace the roof, we can't properly flash the windows. And then there's other windows and on the gable end side of the wall that we uncovered windows below that weren't flashed correctly. So it's like we replaced the roof and it's actually leaking from the windows above the roof as well then we just charge them money to replace the roof, and they still have leaking issues, and that's our fault. And the finger is going to be pointed at the roof. And then at that point, when we suggest, oh, we have to do the windows as well, it looks like we're ripping them off, where we have to go to this customer and be like, hey, we don't know what's under here. In order to be able to guarantee this, like, we need to address these other issues, or else it's the same thing. It's not leaking in the center of this hip roof. It's leaking at every transition area where the step flashing and counter flashing isn't done right. And those are the things that we need to address. Putting on new asphalt shingles isn't going to fix your issue.
Right, exactly. And it kind of sucks because you know, if they ask you for a roofing job and you give it to them, well, they should have asked you for, you know, a flashing job on all the windows or a new window project, right?
Yeah.
You can't be responsible and be, you know, held to that. Oh, I've got a good example for you. So we rebuilt the parapet walls on an old Comrade brick 2-flat in Chicago, and so they're still getting water in one other place. Well, these parapet walls were horrible. They were ready to fall off the building. And then the windows that were wrapped in aluminum, they were collecting water because the way all the joinery was done. You know, isn't that a classic where, you know, these window installers, you know, caulk the bottom of their aluminum casing that they do the brake metal on the job site. Well, those casings fill up with water in a heavy rain, and they were getting water in through that way. So now we're up on the roof. She's got another leak in the pitch pan. She says to me, well, we paid you over $50,000. I shouldn't have a leak. I'm like, yeah, but Allison, we didn't touch this.
Yeah.
Has nothing to do with the money.
There's nothing to do with it. Exactly. So that's why I try to break these things down. And so when there is more water coming into another client's house, it's always something we didn't touch yet. And then that's why I like to do the assessment ahead of time and say, look, it's this, and this. Okay. It's a lot of money. These are deep retrofits, but you go back to the next line. Is okay. Well, let's do this thing because this is the next right thing to do. Let's fix this. Okay. Mm-hmm. And then over time, they finally realize, you know, that they're in deep.
So another issue that I run into on remodels a lot, and it's not quite as much of a concern with brick or even with split face block, because I think that you can do an adequate job kerfing the building and counter flashing that. But
Mm-hmm.
is there something to be said or details that you've sorted out as far as serviceability with the details and the flashings that you're doing on these buildings? And a specific issue comes to mind on a home that we're working on where we're looking to get the roof replaced because there's issues with the roof, and they put a stone veneer on the front of the house, and they basically ran the stone down to the counter flashing, and there's no space right where we go to pull these shingles out and we want to service those flashings, and it's not a flat stone. And I just feel as though nobody put any effort or thought into, hey, what's going to happen 20 years from now when we need a new roof to be able to service these flashings, and not just put shingles up to it and hope for the best. Like, are there things that you do on these masonry buildings to be able to service these flashings and these roofing systems down the road when the roofs need to be replaced without having to peel back everything that's been done prior?
Man, you've either done a lot of research on me or you've been spying on me. Okay.
Maybe both, or maybe I'm just on a shit show of a masonry job right now.
All the above.
Okay, so this is one thing that drives me. Number one is serviceability after I leave. We have to look out for the next guy. So that's the beauty of sheet metal, is being the transition between our materials. So I often use a receiver flashing. Okay, so let's say I've got a roof to wall connection. All of my flashings are going to have a slot bent into the bottom of them. And so the top of that flashing is going to be, let's say we have a siding connection, a roof to wall connection, it's siding on top. So the sheet metal is going to have a little shoulder on it. That's pitch. I like to go 30-degree angle, but it's got a shoulder that's about the same depth as the siding and rain screen that's going to be sitting on top of it. Now, underneath it, you can run your roof membrane up underneath that, or towards the bottom of that receiver flashing, and then you take a simple piece of counter flashing with just a flat stock with a little hem and kick on the bottom, and that's what covers the roof termination. Now, you service your roof, and you're never going to have to touch your siding. I mean, how many times have you guys seen windows with no window casings? All right, no window casings means that the windows are going to go bad in 15 years. I don't care who makes them. Well, hopefully not that quick, but so then you got to tear off the siding. Well, the casing's there for serviceability. I do the same thing with roof, with sheet metal connections. So you can always take the stuff apart, and you never have to remove the stones or the clay tiles or whatever. It's huge.
Yeah, I mean, with vinyl siding, that's one thing, but when you run into these veneers or these stones, I just feel like there's so many better options than what's being done, as far as serviceability goes, and it could save customers thousands and thousands of dollars down the road, and just make for a building that's able to be maintained. Because right now, like, I mean, I could send you pictures of what it looks like on the job that I'm on, and it's like, what are our options at this point? What are we dealing with? Even to put like a counter flashing over an uneven, what around us they call it like a Philly flash, or if they kerf into the building, like when you have a stone veneer that's not really a sightly transition that you want to be making into an uneven stone facade, to be able to make that building serviceable. And it's just disappointing, because at the end of the day, it's like, I can't do my job the way that we need to because nobody put any forethought into this.
All right. That's the trick, man. It's to build serviceability into your projects is leaving behind a legacy where you're going to have every building you ever worked on is able to be, worked on again and again for decades. I mean, it's awesome, but there's so many applications, right? But it's the sheet metal in every case that allows us to make these transitions. It's the connective tissue of the trades, the exterior trades. I mean, that's one of the reasons why I love it so much.
Yeah, and I feel that there's a way to do that tastefully and integrate that into the design as well, that it's not just like, oh, here's a transitional area that's going, like, you can blend that transitional area with design and detailing to make that not only functional but artistic as well, or a design element as well, where I would assume that, being that you're coming from a finished carpentry background and being hands-on and liking to work with that and problem solving and just attention to detail, that sheet metal probably affords you an opportunity to do those type of detailed jobs that you like, and blend the form and the function together.
Absolutely. What's awesome is that get to know, if you got a sheet metal shop that you work with who's got a computerized brake and shear and plasma cutter or water jet cutter, there's nothing you can't do.
Do you guys have one?
I don't. The only sheet metal tools I have are hand tools.
Yeah.
And I've been doing this for, 20 years.
Yeah.
So
I never even thought about computerized brake. That's pretty sick.
Dude, it's awesome.
They're awesome to watch.
I haven't seen it, but I'm about to look it up.
Okay. So, like, for example, we had a building that needed venting horribly. Okay. It was efflorescing like crazy. But at the very top of the building, they had this product called Renaissance Stone. Have you ever heard that name before? It's a precast. And the way you recognize precast stone is it's cleaner, way cleaner than regular limestone, because regular limestone has the ability to hold a little bit of moisture and algae grows in it. But this other precast, it's always perfectly clean because it was engineered to be porous. So during the building boom, especially, people bought all this Renaissance stone as a substitute for limestone. So, make a long story, hopefully not too much longer. Top of the building were probably 5 layers, about 2.5 feet of Renaissance stone stacked up, and it looked beautiful. Everything was kind of corbelled out, but they were getting bids on flashing. And when I met them, I said, look, you can't do this because you flash the top, all the stones underneath it are still porous. You got a hole in your building, and it's this big. So what we did, I designed a sheet metal cornice that had a cove and a crown molding and some other nice flat details and offsets. And so we're doing things like encapsulating the tops of these buildings and bringing back the old art of sheet metal. I mean, these old buildings, they've got these corbels and these cornices that are just so incredibly detailed. Approaching buildings with it, and it's an art form, but you guys got to get to know a sheet metal shop and bring them some presents, get to know them, because they're gonna be the guys who save your ass.
Bob, I would agree. I mean, I think sheet metal is something, I went to a trade school and I spent a little time in the sheet metal shop, and I always had a ton of fun in that shop, and specifically just like what you can do with it, and when you start learning how to do a hemlock and things like, and understand how to bend and manipulate it. I watch guys make these gutters on these handbrakes,
Mm-hmm.
and it's like, and replicate crown molding profiles. It's impressive. But I think that the interesting thing is what you just talked about from like a precast perspective, and someone immediately going to capping that and not fully understanding what that means for the top of the building versus the facade of the building. And I guess to just like repeat, this is where it becomes so difficult, and and ultimately more complicated, to the point where people have a good reason not to do good work, where it's like it's easy to say, you know what, it's too complicated, I'm just going to do what I know and I'm going to keep moving forward. And I think for us as an industry and how it relates to building science is that there is a really big divide between the guys that understand building science and the guys that don't. And there's a few of us, myself included, would be the person that's in between, where I have a healthy respect for building science, but I don't totally understand all the details. And but I will make an effort to make sure I'm doing what is right. And through our social media, for example, I've been called out when I've done things wrong, and I've been grateful for that, because I've been able to learn by way of messing up or making a mistake. But there is still a big divide between the guys that don't understand it and the guys that are leading that change. And I guess one of my questions, like that would be my main question for you, is how do we bridge that, and how do we continue to simplify this?
How do we make it simpler? How do we train the next generation of craftspeople to be able to think across, think holistically, right, across the trades? Now that's that's a big question, because so many people are thinking mono. Roofers don't do masonry, carpenters don't do sheet metal.
Mm-hmm.
And so my guys, it's a little bit painful sometimes, but slowly but surely, all my guys are officially roofers, and they're the guys that are also doing the light carpentry, the sheet metal work, the tent, the reinforcement of the trusses. And it's just, I think a lot of it has to do with just dealing with people who are patient and well paid, and then to bridge the gap amongst the different trades. Man, I'm not sure how we can get that into the system from the very beginning, except because they got to have at least 5 years in each trade to be competent, and it's going to take them 25 years before they can really consider themselves master craftspeople.
Mm-hmm.
This is very similar, and I feel a very similar issue with what you are dealing with where you don't have a holistic view as to, or people don't have a holistic view as to what they're doing. And a very similar situation I feel I come across a lot in remodeling, um, is how people are building shower pans now. I mean,
Hmm.
they have the foam pans now, which have alleviated a lot of issues. I'm not a huge proponent for them for a couple of reasons, but years ago when you had one guy setting the liner, waterproofing, doing the tile, doing the mud work, there weren't issues. And when it switched, I feel like during the boom where the plumbers were doing the liners, so you were
Hmm.
expected to have a tile guy come in, pre-pitch your liner, then the plumber comes in and does the liner, and then the tile guy comes back and puts a secondary pitch on top, or a secondary mud bed on top of that. People got away from doing that because it was not everyone was doing everything. Nobody was looking out for the next trade. And essentially, the plumber came in, put his liner on a flat floor with the drain, with the weep holes, and then there was one single pitched mud bed, which the water got through because tile's porous, grout's porous, the mud underneath it's porous, and then it just sits on the floor and essentially rots for years and years and years. And it's the same thing. It's everyone who's doing their job isn't necessarily looking out for the next person. You're handing off jobs at inopportune times for other people, and nobody has an understanding of the system as a whole. How do all of these components work together? And I feel like in building, um, we're only as strong as our weakest link, and all it takes is one bad move, one poor choice, one inadequate building material, and that could be a failure for the entire job. So I do think that having that holistic view, and vantage point, and understanding what we're doing and how that affects every sequential trade is really, really important. And I feel that over the past bit of time here that we've gotten away from that. We've gotten so specialized and really hammered down on handing every single aspect of every job off to somebody else and then trying to weave and blend them together,
Hmm.
where it you need somebody there who understands the entire project and the entire orchestration of the job to make sure that everything ties in and works together. And I don't think that we have a lot of that right now.
Spot on. By the way, you guys are smart. I appreciate talking with you about this stuff. That the most successful clients I have are the ones who their parents taught them the business at the kitchen table over a bowl of Cheerios.
Hmm.
You know, I mean, right there, you can capture about 10 years worth of experience just in conversation. Like, back when my kids were, my first 4 or 5 kids were,
Wait,
they're all
first
about,
4 or 5 kids?
I've got 9 children.
Oh my goodness, Nikki's
Holy,
got you beat.
he does
Could
have
you
you beat.
imagine saying my first 4 or 5 kids and then you had a second 4 or 5? Jeez.
That's why I'm doing this work, guys. It's the
That's all
most prolific
yeah.
source of work I can find.
Gosh.
So, but we on the way to church, I'd say, okay, what kind of roof is that? And some little girl from the back seat would say, it's a gambrel roof with a hip dormer.
You
Or
don't even know all your kids' names.
oh yeah, I do. I just don't ask me about the birthdates, but I can get within a couple of months.
That's amazing.
But yeah,
Yeah, that I think that's true. Like involving your kids in what you're doing and having them understand and educating them from an early age. Um, there's definitely no shame in that. I can fully endorse and support that.
yeah, but I think that's why we had a reliable culture of building,
Hmm.
because that's how it was before. That's how it was 100 years ago. You
It's
know,
just weird that has changed, and that you know we've said it ourselves that the barrier to entry to be a contractor, a builder is so low. And
hmm.
yeah, some states it's very difficult to get your builder's license, but majority of states and in the US, it's not hard. It's actually quite easy and comical to be able to call yourself a builder or a contractor. And you know, and there is no the training doesn't exist, you know, in the grand scheme of things. There is training out there for sure, but
Hmm.
it's not something that is readily available or being pushed as a necessity. You know, even things like you know, continuing education for your builder's license. It's, you know, yeah, sure, those courses exist and people take them, but they're taking them because they need to, not because they're going there to truly learn and understand it. You know,
Hmm.
and frankly, you know, some of that continuing education, you can kind of set up a, you know, your index finger to hit the next button on the computer screen for 6 hours, and then next thing you know, your building license is good for another 2 years.
Right.
And that's unfortunate because, you know, while that becomes the norm, we continue to make buildings more complex. And it's, you know, this pendulum swing that we're making things more complex and making it easier to be a contractor, and then we end up in the with these terrible buildings that, you know, I referenced earlier, where it's, you know, that, and not to mention, then you have the side, you know, a whole nother rabbit hole, but like then you have the side of like covering it up, where it's, you know, these buildings get sold. Someone asked me the other day, like, how does that builder not get, or how does that developer or builder not get in trouble for something like that? It's like they're gone.
They're
They're
gone.
they're gone. They built that building, the developer sold it, and he's gone. And, you know, and they had a home inspector or building inspector look at it. Yep, you're good. But no one paid attention when it was being built. No one was paying attention to the details and making sure that things were done right. And
Yeah.
the comment about the boom lift, the only person that knows what that boom lift parked on the side of the street means is not the only person, but the population that understands that is so little.
Hmm.
Where it's like, oh, I wonder why they have a boom lift. It's like they have a boom lift because they just built the building and now it's leaking. But no one knows that. Oh, they must have, you know, forgot to caulk something. It's like, no, this is a big issue. And, you know, and now it's like quite literally a joke between my wife and I. It's like, this building, you know, look at that. Hey, see that right there? Like, they're using Tyvek in that situation. They have a deck cantilevered off of it. That's going to leak. And it's just the norm. I I actually talked to someone that lives in one of the buildings. He reached out to me and said, "Hey, I heard you talk about this on the podcast, and I live in one of those buildings, and I'm having issues." And he sent me a video when it was raining and water was pouring down in the wall inside.
Hmm.
And he's like, "Can you please just come over here and just tell me? I don't know what I'm supposed to do." And he's like, "The developer said he'll, you know, he keeps sending guys over to fix it." And it's like, and he's been fine, but it's like, that's not, there's no fix. It's undoing and redoing and putting it back together. I'm going on a tangent here, but my point is that, you know, as this industry pushes to build better buildings, we are pushing, we are making it more complex, and by making it more complex, we are separating those that understand good building and those that don't understand good building more and more. And that's the danger, I think, of what we're talking about.
How about throw on top of all that, the whipped cream is incompatible materials.
Yeah, I think materials are a huge issue. I think
Hmm.
that your example of Doug Fir then versus now is a great example. But the reality is, you know, I don't know if we'll ever have that Doug Fir again. You know, I don't have enough. Like, I don't know enough about that. But the point is that you know, our materials continue to evolve, and I think that we need to be open to that. And something, you know, we've talked about before is, I think my opinion is that the industry as a whole is very romantic about the way we do things. You said it yourself, like, people are so tied to tradition, but the reality is, it's like, I'm not saying that a plastic slate roof is better than a real slate roof, but people automatically assume that it's a crappy roof because it's plastic. We make these like immediate, these immediate assumptions. Why would you use plastic? Just use real slate. It's like, why would you use LVL stud? Just use regular solid stud.
Right.
Why? And everyone just like they're not. Our industry is so protective of our beliefs and our traditions in the way we build that it's we are stubborn by nature and not willing to understand something from a different viewpoint. I've never really given it much thought that our materials are different today than they were, and that could be leading to the issues that we're facing. I just not something I've ever really given it much thought. I do now.
Well, I mean, what's going to save a lot of buildings in my market is the crappy 1.5 fiberglass bats that are sitting in, the typical wall construction is after you've got your block, it might be single wide cinder block, and then they tack 2x2s on the wall and infill with 1.5 of insulation and cover it with plastic before they drywall. Okay. That's I mean, come on, it's crazy. But we find that if you vent the top and take advantage of the stack effect that's natural, right? It's the shitty fiberglass insulation that's going to save all these buildings if they're vented.
If they're vented.
Right.
If not, you have plastic just sealing into the but I mean, that's a whole nother issue with venting and people understanding that. One thing that even you talking about your venting detail for your rain screen, what speaks to me about that is you're leaving nothing up to chance. I've seen how other people have come up with solutions as to how to vent rain screens. And a lot of times it's like running the rain screen up and then putting a block that they could then put a piece of trim over and keeping the siding down from that to leave like an air gap.
Mm-hmm.
And to me, it's just like I see the siding guys coming in and jamming their siding up tight to that block and then completely defeating the entire purpose of that. Where like the detailing that you're doing on that rain screen, there's no siding contractor who's going to come in and screw that. It's unscrew upable. And I think that a lot of times that's the way that we have to approach what we're doing with all these different trades involved to ensure that things are properly vented, that buildings, even though they're high efficient, can breathe, that we're properly managing our water intake. And if water is getting out, we have a way to mitigate that and take care of those potential issues. But I think it's super cool what you're doing. I enjoyed looking into it, and it's not something that's typically right up my alley, but I was kind of geeking out over it a little bit. It's very interesting, and like you said, I think that it's a bigger issue than people realize, especially in older cities where you're dealing with a lot of these flat roofs and parapet walls that have no sort of venting whatsoever.
Well, I mean, a couple of thoughts that I would, leave with you guys is that, every masonry structure out there is a reliable source of work for us. At least, that all these systems, they all behave the same. It's just that the only difference is one's soft and one's hard, but you still need to do the same thing. Let's say if we got a triple wide or double wide old building, the way we vent the top of that building is take off the clay tiles, remove the mortar, and then we've got this fabric. Okay, and Diane, who works for me, hates it when I say this, but what we do is we put a little piece of plastic down the middle of that old wall, okay, and then we take a fabric that's the same thing that's on the bottom of your box spring, okay, that black woven fabric.
Yeah.
Get a sample of it sometime, okay. It's very common in furniture making. It'll hold the surface tension of water, but it has a perm rating of about 108, so you can almost see through it. So then we stretch that and we glue it to the top of the wall, and then we take the clay tiles and glue them back down with 4 blobs of caulk back around on the bell where they connect. We did that one time. That was an experimental job that went really good, where they've all gone good. But in this case, there was spray foam applied to the inside of this old building. It was repointed with too hard a mortar on the outside. The house filled up with water to the point where the air conditioning shut down. Well, when we did this process, a couple of months later, the air conditioning kicked back in. And it had that much water. And so what was interesting was that in that particular job, when we vented the walls, there was such a rush of water to the top of the parapets, it warped the 1x6 extension jambs off the wall on these new windows. I mean, the client called me up and said, I've got this nasty smell from behind my warped window casings. And for me, I was like, I couldn't tell you how happy I was because it told me exactly what was going on, you know?
Yeah.
It was so exciting. It was like, oh, and now we do this on, clay tiles. You just need a corrugated plastic and this fabric. I call it the magic cloth. Now you can force water through it, right? But it will resist it to some level. It's not waterproof, but it's good enough. And the cracks on the sides of those, the air gaps on the sides of those clay tiles to the brick might be a 16th. That's another thing that I've been trying to pay attention to is how little airflow do I need to make everything work. So you don't need a lot, you just need a gap. So
yeah, I think that's something that comes up a lot where it's like you talk about rain screen. It's like, well, how big? And then everyone's, there's always discrepancy in that conversation. For something that you said earlier about like when they detail, or I think it was Tyler, you were talking about like the brick veneer and it's drawn with that gap behind it. But it almost is interpreted as here's where a face of brick is and here's where a face of sheathing needs to be. Anything between that is fair game. Where it's, for us, like we were talking about, we had a detail with the brick veneer and we were talking about how big of a gap we needed. And we ultimately ended up with a pretty small gap. We used that, I forget what it's called, but it's like a cedar breather with a felt on top of it. Essentially just enough to make sure that we're not slamming the mortar up against the wall and preventing the mortar from going through that breather.
Yeah.
Home slicker, I think it's called. But it's always interesting to understand like the work that goes into it. Something like for you in product testing and understanding how small that gap needs to be and understanding that all you need to do is just make sure you have airflow.
Product testing, man. Product testing for me was, okay, let's give this one a try. And then on the next one, how far can we push it? Right. Yeah. And then the next one, how far can we push it again? So I just figure I've just been walking around with the biggest bag of spitballs. I just keep on throwing them against the walls and see what sticks.
There you go.
So far,
can't get any worse.
It can't get exactly. It can't get any worse.
Well, I definitely appreciate your insight. Food for thought for myself, food for thought for all of our listeners, which I think is especially important because typically people they just have the mentality of, hey, it's a stone building, it's a masonry building, nothing can rot, there's no issues, water management is not the biggest concern, and obviously it is. And you're coming up with different ways that you can handle that from a retrofit perspective and a new construction perspective. So I appreciate the insight. I appreciate your time, and definitely food for thought. It's interesting. It's nothing that I've really dwelled on too much. I don't come across it that much, but when I started looking into it, I was like, yeah, this definitely is a big issue, and I can see the benefits of this. So I appreciate getting my brain spinning and keeping me mentally engaged for a few hours.
Speaking of food, what's for dinner tonight? 500 sushi rolls, or
you know what? Whatever it is, it's going to be awesome.
I'll keep rubbing it in. Sure.
There's 3 courses, and you're full by the second course.
Yeah.
And then they bring out the main course, and I think there might be a semi full of liquor stashed somewhere nearby.
There you go.
Good wine.
Sounds productive.
That's what makes it interesting.
But you know what? You guys would love this because last year was my first year of going to this. and I'm walking down. He's got a long driveway on his property, and all the people that you meet, you say to yourself, "I've met my tribe."
That's cool.
Yeah, it's pretty cool. Well, you guys are, wonderful hosts. I appreciate, being on and talking with you guys.
Yeah, I appreciate you making the time.
Yeah, absolutely. Especially being that you're away and on a little bit of a work retreat. We appreciate you making the time for us.
Oh, you guys, I was looking forward to this. In fact, I talked to my girlfriend and I said, I'm kind of nervous. What am I going to do?
Nah, you're good. You did great.
Yeah, you didn't seem nervous at all.
Oh, thanks, guys. I appreciate it.
Sure thing.
Cool. All you got to do is hit that leave studio button and just leave the browser open just for a minute. It'll let you know that you're 100% uploaded, and then we're good to go, man.
Okay.
Yeah, and then we could send you all the details as far as when it gets released, all the information, all the teasers, thumbnails, all that stuff. We'll shoot over to your email.
Okay. You guys are doing a great job. I've been having fun listening to the other episodes. So
I appreciate
cool.
it.
Thanks so much. Yeah, we appreciate it. It's been fun.
My pleasure. Thanks a lot, guys.
Thank you.
Hopefully I can figure this out. All right. Take care now.
The complexity is just what scares me, man. And I feel like I feel like I'm being, especially after the conversation a couple weeks ago with Austin, it's like, are we making things more complex? And I think what he's doing is awesome. Looking at the details, when you guys were talking, I'm just looking at all like the details on his website, and I'm like, yeah, this all makes sense. Why isn't this just a standard detail?
Yeah.
And that's what's weird.
I mean, it absolutely should be. And I really do feel that it's just the way that our industry has changed and evolved over time. It's been slow. Like if you look at it, it has not been fast. I think in recent years there's been a huge resurgence of new products and systems. But over the past 100 years, like things haven't changed that much, and we've integrated some new system. I mean, like before Tyvek, what else? There was builder's paper as far as WRBs go. Yeah, but like it was felt and then Tyvek type materials, and then not until 10 years ago did they really start implementing in residential construction all these other options. So I feel like we've been slow to change, and with one change at a time, obviously all of those changes start coming together, and materials that don't play well with each other ends up creating some big issues. But I it is definitely food for thought that, like, hey, masonry buildings, why shouldn't we be addressing the same concerns that we have with every other type of structure? At the end of the day, that masonry should just be a finished material on the exterior. We still have everything on the interior to worry about, and water management shouldn't be that much different than what we're doing with any other exterior finished material. So I enjoyed it. It was cool looking it up.
If you want to check out that website with all those details, it's wickwright.com, WICK, right, RIGHT.com.